Okay, so we'll talk about this a little bit more and then we'll go on to solve this problem here. What we're asked to do is to find the equation of the normal line. And you can see where the normal line is. It's just a linear equation that has a point slope form to it. Y minus y1 equals m times x minus x1. We need a slope and we need a point. Well, the point is going to be the point of tangency, the x and y coordinates of the point of tangency as it's labeled in this particular graph. The slope, m, is not going to be the slope of the tangent line, but it's going to be the opposite and reciprocal, or the reciprocal of the slope of the tangent line and opposite sign. So what we need to do is find the slope of the tangent line at some point a, some x value a. We'll call that f prime of a. And we're going to take the reciprocal of that and change its sign. So we're going to take the reciprocal of the slope of the tangent line and change its sign. And the x1, y1 value, well, they are the coordinates of the point of tangency. And so that's all we need to do. We're going to plug them in and find the equation of that line, just as we did with the equation of a tangent line. The only thing that's different here is that instead of using the derivative at a particular x value, we're going to take the reciprocal of that derivative, change its sign, and that becomes a slope of the normal line, the line that is perpendicular to the tangent line at the point of tangency. I hope that's clear. We'll go on now to look at problem number 18 or 19, whichever. Okay, so it is problem number 19, and we're looking for the equation of the normal line. So in order to do that, we start, remember, by finding the slope of the tangent line, which is the first derivative evaluated at x equals 2. And since the basic structure here is a quotient rule, we're going to use the quotient rule to find the first derivative. We have low, d high, the derivative of the numerator is just 1, minus high, d low, and the derivative of the denominator is 2. And so the denominator is 2x minus 5 quantity squared. Right? And what we're looking to do is find this value when x is equal to 2. We don't really have to simplify since we're trying to find a specific value of the derivative. We just plug in x equals 2. So f prime of 2 is 2 times 2 is 4 minus 5 is negative 1 times 1 is still negative 1. Then x plus 3 when x is 2 is going to be 2 plus 3, which is 5, times 2 is 10. So we have negative 1 minus 10. And the denominator is going to be 2 times 2, which is 4, minus 1 with minus 5, which is negative 1, and negative 1 squared is positive 1. And so the slope of the tangent to the curve is negative 11. And what we want to do is take that negative 11, and we want to find what is the slope of a line that's perpendicular to that line. Well, the slope of the normal line is going to be the reciprocal of the slope of the tangent with an opposite sign. So it is just 1 over 11. Okay, so that's the slope of the normal line, 1 over 11. We did it exactly the same way we would have done the tangent line, only we're going to take the reciprocal and the opposite sign. Alright, so we have all the pieces except we still need to find the y value that goes with x equals 2. So we're going to plug 2 back into the original function, and we're going to get 2 plus 3, which is 5, over 2 times 2, which is 4, minus 5, which is negative 1. So when x is equal to 2 in the original function, y is going to equal negative 5. And so the point of tangency is x equals negative 2, y equals 5, and the slope of the normal line is 1/11. So we're ready to put that all together, and we get y minus y1 equals m times x minus x1. I'm sorry, the coordinates were negative 2 and negative 5. So it's going to be y minus negative 5, which is y plus 5, is equal to 1/11 times x plus 2.